Let's take a look at how the Science DMZ supports TCP-based bulk data transfer. So the key components of the Science DMZ, right, the dedicated network enclave, the dedicated data transfer nodes, the performance engineering infrastructure in the form of Personar, and the tailored performance security policies and policy enforcement mechanisms all work together synergistically to provide an environment where TCP can perform well in the general case. So networks provide connectivity between hosts. How do the hosts see the network? The hosts, and more importantly, the data transfer applications running on the hosts, see the network not as the collection of routers and switches that a network engineer like you or I would see, but they see the network as a socket. Right? A socket looks an awful lot like a file descriptor. The application makes a call to the kernel, gets back a socket that represents the connection to the remote data transfer node. The application can read from and write to that socket just as it would a file, and the remote data transfer node is involved in the other end rather than the file system being involved. But in principle, it's the same. The kernel makes two promises. One is that data will arrive reliably and in order across that socket, and if the kernel is unable to provide that first guarantee, the kernel will return an error. There's no guarantees made about performance. And so in order to make sure that TCP performs well, we have to accommodate it at the infrastructure layer. So I like to call TCP the fragile workhorse. TCP is a workhorse because it's by far the most widely used data transfer protocol. Certainly in ESNet, over 95% of our traffic is TCP. I call it fragile because in the presence of packet loss, TCP backs its sending rate off, and so performance suffers significantly as a result of packet loss. And so how much does it suffer? If you look at this chart, you can see that it suffers quite drastically, in fact. And the thing that's tricky about this is that performance suffers a lot more as the distance between the communicating hosts increases, and performance doesn't decrease very much at all in the local area. So this is one reason why local performance tests don't really tell us very much about wide area performance problems. So if we look at this plot, on the y-axis is its linear throughput, 0 to 10 gig, and on the x-axis is the round-trip time in milliseconds between the communicating hosts. The purple line shows a set of performance measurements with no packet loss. The other lines show performance measurements, either real or simulated, with a packet loss rate of 0.0046%. That's about 1 packet in 22,000. So it's very, very small packet loss rate. But you can see that in the local area, it doesn't impact performance all that much. In the metro area, it impacts performance quite a bit. As soon as you get outside your metro area, you've taken a huge performance hit, and it simply doesn't improve from there. And so in order to reliably achieve high performance over long distances, it's absolutely imperative that TCP see a loss-free IP layer. So how does the Science DMZ help with this? The Science DMZ helps with this problem in 3 ways. Provides sufficient capacity, so the local infrastructure is well matched to the capabilities of the wide area network. The Science DMZ components have a better performance profile than commodity components. They're engineered to be able to support high data rate flows. In particular, look at the per flow data rate that you can achieve using the devices that you're going to use to build your Science DMZ. And the security model that's used for the Science DMZ is specifically designed to support high performance. So we limit the application set that's deployed in the Science DMZ, and so that allows us to be very prescriptive, and it also allows us to use high performance devices rather than highly complex firewalls in order to provide the security for the devices in the Science DMZ. So if we then map this back onto the Science DMZ design pattern, you can see how the simplicity of the data path from the wide area and dedicated data transfer node and the dedicated Science DMZ and the Personar infrastructure all work together to provide a high performance environment for TCP-based bulk data transfer.